Okay, so now we will discuss about numerical integration. Okay, so as I mentioned, in case of numerical integration, we will follow some approach that will give us the result without implementing any formula, right? Will not use any formula of integration. Rather, we will follow alternative approach. Okay, so we are discussing about numerical integration now. Okay, by the way, I should mention one thing to you all, that we will arrange problem solving sessions. Okay, after completing the next session, hopefully the next session will be our last lab session, then we will arrange problem solving session, right? So by I want to mean by problem solving session is that I will show you some example problems and try to solve using MATLAB, so that you can get an understanding what type of problem uh, can be you will face in the simulation exam. Okay, so in the next session we will complete our labs and then we will arrange problem solving session. So you don't have to worry for now. Okay, just keep the concepts clear and also understand the codes, and we will solve problems before the simulation exams, similar type of problems, or at least I will try to give you some hint what type of problem you will face in the exam. Okay, so as I mentioned, in case of numerical integration, we won't use any formula, we will use alternative approaches. So the first approach that we will follow is called the trapezoidal rule. This is pretty much intuitive. Okay, this rule is pretty much intuitive. So in case of trapezoidal rule, by the way, moving on to the trapezoidal rule, one thing I should mention, or one thing you should say, that what is the geometric interpretation of integration? What is the geometric interpretation of integration? মানে ইন্টিগ্রেশনকে জ্যামিতিক ভাবে আমরা কি বলি বলেন তো? ইন্টিগ্রেট করা মানে
Trapezium or rectangles.
না, ওইটা ঠিক বললাম না। আমি যেটা বলতে চাইলাম যে ইন্টিগ্রেট করা মানে আমি যদি আপনাকে একটা কার্ভ দিয়ে দিই, ইফ ইউ হ্যাভ বিন গিভেন আ গ্রাফ and asked to integrate in between an interval, then what you will actually do?
Sir, we will find the area that is underneath that curve within that given interval.
Exactly. That what was I looking for. So the geometric interpretation of integration is actually finding the area under the curve, right? So integration is the equivalent operation of area under any curve for any given interval, right? Area under the curve. If we have been given any curve, then if we determine the area, then we can say we are actually performing the integration. So trapezoidal rule is based on this idea, okay? Based on this idea. So let's assume we have been given this curve. You have to write the code for the trapezoidal rule for yourself. So I will try to give you the idea, and hopefully you'll be able to write the code in MATLAB. So let's say, assume we have a function that looks something like this. We have been given a graph. Let's assume that looks like this. Okay, so this is a random graph. So we have to integrate this function. So this is our x-axis and this is our y-axis. So we have to integrate this function. Y is actually f of x. Y is f of x. So we have to integrate this function. Let's assume from this point to, let's assume, this point. So let's assume this is our x1, or let's assume this is our starting point x1, and this is our ending point. Okay, so this is x2. So determining its integration actually means that we have to find this area, right? We have to calculate this area. So how can we calculate the area under a curve? Okay, so we can calculate the area under a curve. The simplest way that we can follow is making a trapezium. Okay, so what we can do, we can consider these coordinate. First we will follow, I will go, or I will show you some method that's inaccurate, and then we will go for more accurate methods. Okay, so let's assume we have this point here, and the y value is f1, and we have this point here, the y value is here, so this is f2. Okay, f2 is actually the y2, or f1 is actually the y1. So to determine the area under the curve, we can make a noob approach, or a very inaccurate approach first, then we will go for the more accurate ones. So what we can do, we can form a trapezium. We can form a trapezium that looks something like this. So this is the trapezium that we have formed. So if we calculate the area of the trapezium, we will get this portion, right? Okay, so now can anyone say what is the formula of area of trapezium? Yes, please share.
Half into
Half into.
what? I forgot.
Okay,
Sorry.
okay, okay. So the area of the trapezium was this. That if we have a trapezium that looks something like this, then we have to consider two aspects. The first one is the length of the parallel sides. A trapezium has a pair of parallel sides, right? So let's assume this parallel side has the length of A, and this side has the length of B. And also we have to consider the difference in between the parallel sides. Okay, distance between the parallel sides. So we have to consider this distance. Let's assume this is H, or whatever. Let's assume this is D. So the area of a trapezium is equals to half times the summation of the length of the parallel sides. So it means A plus B times the distance between the parallel sides, D. Okay, so the area of trapezium is half times the summation of the length of the two sides, two parallel sides, and we have to multiply their distance, okay, the distance in between them. Okay, so this is the formula for the trapezium. So now if we implement this in our purple color trapezium, implement this formula in our purple color trapezium, what we will get? So if I want to calculate the area of this purple color trapezium, what is the length of this side? So this is one parallel side, the left one. Can anyone say what's the length of this side? F1, right? The y value. This side, I am referring to this left side. So the length of this side is its y value, right? So we will get the area as half times this length is f1, and if we look for the length of this side, the right side right parallel side, this one, then its length is the f2, right? This y value. So f1 plus f2 times d. D is the difference in between them. So this coordinate was x, and this coordinate x1, and this coordinate was x2. So we can write their distance as x2 minus x1, right? So we can consider their distance x2 minus x1. So it would be the area of this purple color trapezium. Okay. So here is the issue, that this purple color trapezium has a very large error, because we cannot calculate, or we are actually not calculating this portion, right? We were expecting that we will be able to calculate this portion in the integration, but we have not been able to calculate this white color area. This area has not been considered. So there is a very large error. So can anyone suggest what we can do to minimize this error? Any idea from anyone? We are willing to follow the
Take
trapezoid.
smaller sections, sir.
Exactly. So we will do this thing. We will consider actually smaller sections. So what we are going to do, this is our y equals fx, this is x. So if I paste the curve here, so it was our curve. We had to determine the area from this point. So this is our initial starting point x1, and it was our final point x2. So what we will do is that we will consider very small trapeziums, very small sections. Like we will consider the first trapezium that will have this segment. So it will be our first trapezium, and we will consider that this trapezium is so close to x1, or its other coordinate is so close to x1, we can consider this coordinate as x1 plus h, where h is a very small number. So if this coordinate is x1, then this coordinate is x1 plus h, where h is a very small number. Then we will consider another trapezium that will look something like this. And this x coordinate is equidistant. So this coordinate can be considered as x1 plus twice h. So we have moved h, and then we have moved 1h again. And we will continue to do this thing. We are willing to divide this graph into small such trapeziums, so that we can assume these are straight lines. These small portions are our straight lines. Okay. So then we will consider one more small trapezium here, and its coordinate will be x1 plus thrice h, and so on. Our total portion will be divided into, let's assume, n number of segments. Okay, so if our total portion x1 and x2 is divided into n number of segments, we can write x2 as x1 plus nh. We can write x2 like we have got x1 first, then we have got x1 plus h, then we have got x1 plus twice h, x1 plus thrice h, and as we are dividing it in n segments, x2 will be equal x1 plus nh. We can write x2 will be x1 plus nh. Okay. So now if we calculate the area of these trapeziums, these small segments, let's assume this is our f1 now. This is f1. Let's put the graph. here. Okay, so let's assume this is f1. So this is the corresponding y value of x1. Similarly, if we want to calculate the corresponding y value of this point, let's assume this is f2. Similarly, for this point, let's assume the corresponding y value is f3. Then for this one, this is the corresponding y value. So let's assume this is f4 and so on. So now if we calculate the area of the first purple color trapezium, this one. So what would be its area? So the purple color trapezium will have the area as half times the length of the parallel sides, right? So this left side has the length of f1, right? This f1, the y value, corresponding y value. Which was the f1. So this length is equals to f1. This length, okay. This length is equals to f1. Then we have to calculate the length of this right side of this purple color trapezium, and this is f2, right? So f1 plus f2, and then we have to calculate the difference or the distance in between the parallel sides, right? So the distance we will get is x1 plus h minus x1, right? So we will get the distance as h. There h time they are away from h times distance, right? So this is the distance. The distance will be x1 plus h minus x1. So the area will look something like this: half times f1 plus f2 times h. So it would be the area for the purple color trapezium. Okay, let's consider this green color trapezium, the second one. So if we calculate the green color trapezium, what we will get, the area would be half times the parallel sides, right? So the parallel side length one is the f2, this green side. This green side will have the y value of f2. So this is f2, and the right hand green side, so this green side will have the length f3, right? It would be f3, and this distance is h as well. If we subtract these, x1 twice h minus x1h, we will get h as well, right? So it would be h, because all of them are h distance apart from each other. I will add one more term and then we will make a statement. So lastly, if I consider these red color trapezium, can anyone say what would be its area? So what would be its area, the green colored trapezium? Half times, then what we will get?
f2 plus f3.
f3 f4 না, এই যে দেখেন এটাকে আমরা যে f3 কনসিডার করছিলাম, একটু জুম ইন করি। এই যে এই লাল কালারটা যেহেতু আমরা কনসিডার করতেছি, লাল কালার হচ্ছে এই সাইডটা, এই সাইডটার কোরেসপন্ডিং কোঅর্ডিনেট হচ্ছে আমরা f3 কনসিডার করতেছিলাম আর কি। হ্যাঁ, লেফট সাইডটা ছিল f3, তাহলে f3 প্লাস f4 আসবে, তাই না?
f4, হ্যাঁ,
এক্স্যাক্টলি এক্স্যাক্টলি। সো উই আর গেটিং আপ, okay, ঠিক আছে। So we are actually getting a pattern, that's important. So we will get f3 plus f4 for the right hand side, and the distance in between the two sides is h as well. So what we have to do, let's assume this is a1, the first area, then it was the a2 for the second trapezium, this is the area for the third trapezium. So if we add the areas of these n trapeziums, then we will get the total area, right? As I mentioned, x2, this whole segment has been divided into n small trapeziums, so that we have written x1 plus nh. So if we add all these areas, so the total area would be summing from 1 to n. If we want to write the expression in terms of summation, we will write it separate manner. We will get a1 plus a2 plus a3 plus dot 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 up to an. The an will be this last trapezium from here to here. Will be the last trapezium. Okay, so if we look carefully, then we will get a pattern here. First of all the areas have half common, and all the areas have h in common. So if we take these portions common, then what we can write, we can take this half and this h common, and all these portions will be get added, right? So we will get f1 plus f2 for the a1, then we will get f2 plus f3 for this portion, for the green color. So it was from the purple color area, it was from the green colored area, and then we will get f3 plus f4 plus dot dot dot, and lastly we will get fn, or the last y value, right? So can anyone see any pattern, or can anyone make any observation from this expression? এখান থেকে কেউ কোন স্টেটমেন্ট মেক করতে পারেন বা অবজারভেশন শেয়ার করতে পারেন এই 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 অংশটা থেকে? বলেন তো এটা দেখে কি মনে হচ্ছে? Can you make any statement?
2f2, 2f3 equal.
Exactly. So we have 2 f2s, we have 2 f3s, and similarly we will get 2 f4s, but we will have only one f2, only one f1, and we will have only one fn, because f1 will be considered only once whenever we are considering these purple color trapezium, right? And fn will be considered only once when we are considering these last trapezium. But the other terms are considering twice because they are common in between two trapeziums. Like f2 was common, this common side was the f2. Similarly f3 was common and f4 was common. Only f1, the starting y value and the ending y value, will be considered once. The others will be considered twice. So if you get this pattern, then what we can write is that we can make f1 and f2 out here. So we can write, sorry, f1 and fn. You can write f1 plus fn, and the rest of the terms can be written as half times h times 2f2 plus 2f3 plus 2f4, right? So I have separated these two and brought these two together. So we can divide, we can cancel out these 2's with these half, right? So these half and these 2's will get cancelled out, and so the area will look something like this: half times we can write it as, if we take common the h, we will have f1 plus f2 plus, here we will have h or we can take the h common also. We take the h common, we will take the h common, we can write it in this manner. f1 plus f2 divided by 2, we are considering the half here, and then writing the rest of the portions, like so fn, f2 plus f3 plus f4 and so on. Okay, so we are taking the h common. So if we take the h common, we will have this portion f1 plus fn divided by 2, f1 plus fn divided by 2, and in this portion we have taken the h common, and these half and 2's will get cancelled out. So it will be the expression for the trapezoidal rule. Okay, very very simple way to calculate the integration for any given interval, and the smaller segment can we make, the more accuracy we will get. Okay, if we take the segments larger, then there will be much error, but if we can take the segment smaller, then we will have better accuracy. So similarly, the accuracy actually depends upon the value of h. So if h is smaller, we will have our calculated integration more accurate. Okay? But if h is large, then there would be some error, because if h is large, we cannot consider these small portions as straight lines. As we have considered these as straight lines, these straight lines will not then fit with these curve. Okay, like what I tried to mention is that if we consider large h's, like we have this graph, if we take the value of h larger, then what will happen is that, let's assume this was our x1, and this is x2. So let's assume we are taking the h larger, so we may consider this trapezium. So the value of h is large now, so h is now this portion, this is the h. Then our second trapezium will be here, so this coordinate will be x1 plus h, this coordinate will be x1 plus twice h. Then let's assume it would be our third trapezium, it would be x1 plus thrice h. So now if you can see, if we consider these trapeziums, we will have some error as well. This would be our first trapezium, then it would be our second trapezium, then the third one here, and the fourth one will look something like this. So in each cases we are actually getting some error, like here we are not considering this area, here we have considering these extra area, here we are not considering this area, here we are considering these extra area. So we have some errors. So the bottom line is, in case of trapezoidal rule, the small h you take, the better accuracy we will get. Okay. Okay, so what you have to do, you have to write the code of the trapezoidal rule yourself. I'm giving a hint. The algorithm will be given in the lab sheet. Okay, the general algorithm will be given in the lab sheet. I'm just giving you a hint. What you have to do for the given interval, like x1, x2, you have to make small segments. Okay, so if x1 and x2 is given, you have to first define an interval with small segments. Like if x1 is given as 2 and x2 is given as, let's assume, 7. So what you can do, you can define an array that will start from 2 and end at 7. So you can define an array of x that will start from 2 and end at 7, and the interval should be small. So you can consider the interval at 0.1. Okay. So for each of the intervals, you have to now calculate the y value. So if our function is given, if f of x is given, some function, then you just have to calculate. So f of x can be written as the inline function, as I mentioned. If the f of x function is given as the inline function, you write the expression for the function here, and then just calculate the areas. First, you have to calculate the area of the starting and the ending point, right? Because and this is our h, right? So our h is 0.1. You can consider h to smaller value as well. H is 0.1. I guess you are familiar, you can recognize this expression, right? So in MATLAB, if we write this thing, we are actually doing this thing. We are defining an array, starts with 2, then we get 2.1 with 0.1 interval, right? 2.1, then 2.2, then 2.3, dot, 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 up to 7. So we are defining this x array, and we have defined the f inline function. So f has been defined as the inline function, and then we can calculate their y values, right? So if we put f of x1 or f of 2 in the code, right? So if we put, we calculate the area starting with this, that f of x1, the starting point, plus f of x2. x2 is our ending point here. So we are calculating this portion, the initial point and the ending point's y coordinate. So these are the y values of the initial and ending point, and we will divide it by 2. Then you can just divide it by 2, and then you can run a for loop. You can run a for loop that will add these y values, the f2, f3, f4 up to the n minus 1, the n minus 1. So you can run a for loop with, let's say, I equals 2 and n minus 1, or the length of this x. You have to calculate the length of this x array, length minus 1, length of x minus 1. Okay, so length of x minus 1 will give you these points, excluding 2 and 7, excluding the starting point and the ending points. So you just have to then calculate and sum with a. So you can write a equals a plus f of function of xi. Okay, we are actually considering these values, right? So f of xi, we are calculating their function values. So then f2, so it means we will have f2 here, then f3, f4, these portions, the portions that were multiplied by 2. So as all these portions will be calculated, then what you have to do, you just have to divide, or you have to multiply the whole thing with h. So the ultimate area would be the area calculated earlier with the h. As we have mentioned h as 0.1, you can multiply it with h. So I guess you will be able to write the code. I'm just giving you the hint. The algorithm is also given. Okay, so hopefully you will be able to write the code. I guess uh, you get the idea how you can implement trapezoidal rule in MATLAB, right? Any queries about these algorithm or trapezoidal rule? ট্রাপিজয়েডাল রুলটা কি বোঝা গেল ভাই? অ্যালগরিদমটা কি বোঝা গেল মোটামুটি? কিভাবে কোডটা লিখবেন নাকি বোঝা যাচ্ছে না? মোটামুটি কি বোঝা গেল? আচ্ছা আচ্ছা, একটু ম্যাটল্যাব ইয়ে করলেই পারবেন, এটা কঠিন না, একদমই সহজ অ্যালগরিদম। হ্যাঁ, এটা অ্যালগরিদমটা একদমই সোজা। ওকে, নাও what we will follow is that we will follow adaptive integration. Okay, we will follow adaptive integration. So in case of adaptive integration, we don't set the fixed value for h. Okay, we don't set the fixed value for h. Why? Because, okay, let's make a break here, then we can